To another video of Math Magic with Jen. We are starting Unit 4 today with this video. And this unit is going to be on a bunch of topics that are taught mostly in 6th grade, a couple in 4th grade, but hopefully you find them interesting. This first one is on ratios. And as it says here, we're going to look at notation, tables, and tape diagrams. All right, so what is a ratio? Good question. A ratio is an ordered pair of numbers. It can be denoted with this A:B. But even when we read this, we'd read this A to B. So even if we have this, we'd say A to B. And this establishes a relationship between two numbers. And what's most important with students when you're working with ratios is that they need to understand that this relationship is assumed to be constant unless we are told otherwise, meaning that for the entirety of the problem, we're going to have the same ratio. All right, so let's do an example. We might be told that the ratio of 6th grade girls to boys is 3 to 4. That means that for every 3 6th grade girls, there are 4 6th grade boys. Okay. So we can write it a few different ways. 3 to 4 with the colon, using the word to, even using a fraction. Excuse me. Now, super important, if you want to flip the order and talk boys to girls, which you're completely allowed to do. Let's say that we decided to talk about, well, what happens if we switch the order and the boys are first? Well, that means then that the 4 comes first. So the reason why it's called an ordered pair is that the order matters in terms of what it's representing. So in this problem, 3 is representing girls, 4 is representing boys. So if we reverse the order, we reverse the order. Okay. Now, let's talk about how to visualize this ratio, and we're going to start off first with tape diagrams. Now, we're going to do tape diagrams a little bit differently for 6th grade. So you can see right here, they even look a little bit different because typically if we were to draw a tape diagram of 3, we'd actually have, 3 little boxes, right? Each one representing, one element. That is really tedious and honestly ridiculous for 6th grade because what we're going to be doing is we're going to be basically copy and pasting these ratios to solve problems. So we might be drawing the equivalent of 24, and I don't want to actually draw out 24 single boxes, okay? So what will happen here is we are going to have one tape diagram, one individual box that equals 3, and because the other number is 4, we're going to draw it just slightly bigger. It doesn't need to be to scale, but I do want to show that one is smaller, one is bigger. And typically we'll even label it. So here's girls and here's boys. Okay. Now, how this works is that to get an equivalent ratio, what we would do is we would build it up. Meaning that if I built up and added another 3 girls, then that means I'm going to add another 4 boys. So every time I add a box or piece to one tape diagram, I have to also add it to the other because our ratio is staying constant. So in this instance, an equivalent ratio of 3 to 4 is also 6 to 8. And as you can see down here, if we added a total of 3 boxes, then that means I have to have 3 4s. So this would be 3 plus 3 plus 3, or 3 times 3. And adding 4 3 times, and I get the ratio of 9 to 12. So these are all equivalent. So, by the way, before I go to the next slide, if you wanted to write it in fraction form, because that is one of the options for writing ratios, this is saying that 3 to 4 is equal to 6 to 8 is equal to 9 to 12. Or reading it as fractions, these are all equivalent fractions. 3/4 is equal to 6/8 is equal to 9/12. So you can always delve into the world of fractions to also have that aha moment of that they're equal. Okay, remember this is 6th grade. 6th grade. So we're talking about 12-year-old basically. Okay. How to use tape diagrams to problem solve. So here we've got a word problem, and there are lots of word or story problems in sixth grade Common Core textbook. And this one says, suppose we were still using the sixth grade ratio of 3 boys to every 4 girls. If there are 24 sixth grade boys, use a tape diagram to solve how many sixth grade girls there are. So we're going to have a total of 24 boys, and we're trying to figure out what does that mean for girls. Okay. This we're going to solve with tape diagrams. In just a little bit, I'll show you another method that is tables and also kind of leads us towards algebra skills, okay? But for right now, idea would be we'd ask our students, how many of these brick or pieces of a tape diagram would I need to have total to get to 24? So they could draw them one by one, right? So here's another 4, so that's 8. Another 4, that's 12. Another 4 is 16. 20. 20. Oh, I almost wrote 24. 4 more is 24. Okay, now, some of you are going to go, well, what if my sixth grader knows, hey, 4 times 6 is 24, so I need 6 of them? Awesome. Yes, that's even better. Both ways work. Whether you have someone coming along and writing 4 each time or figuring out how many total they need to write, that's totally fine. But the point is that we have a total of 24. Sorry, that's there. We're just going to ignore it. We have a total of 24, but more importantly, I have to draw 6 pieces or the first and then 5 more pieces. Well, we got to do the same up above. So every time I drew a 4, so I'm going to need to draw a total of 6 3s. So I already have 1. Here's 2. Here's 3. Here's 4. Here's 5. Here's 6. Okay. So when I total all of these up, I find out that I have 18 girls. There we have it. Okay. Now, some of you may be watching this and thinking, what about algebra? What if I wanted to show them a more algebraic way to solve it? I mean, yes, that's totally fine. I will say you will have some students who like the challenge, are going to be curious and come up with their own hypothesis of how to solve stuff. So what we could say is we could have the students realize, oh, I had 4. I had to draw 6 total. So that's telling me then that he has to also 6 total. So that's almost an algebraic way. Another way that you can think of it is that we're asking, if you want to think about it as fraction form, 3 to 4 is the same as what to 24. That's really the same thing that we're solving. So again, we're focusing right now on tape diagrams, doing a visual answer to this, but technically you can start to kind of head towards algebra. Okay. We have one more problem to do, but before I get there, they do ask one extra question. So sometimes Common Core textbooks will sneak in questions that don't really have anything to do with the ratio tape diagram solving. It's just like a follow-up question. So here, if I have 18 sixth grade girls and 24 sixth grade boys, then I think I'm going to have 42 total. So this is just adding up our total. Okay, let's do another one. One more. Promise I'll be more succinct on this one. Okay. Josie took a long multiple choice end of the year vocabulary test. The ratio of the number of problems Josie got incorrect or missed to the number of problems she got correct is 2 to 9. If Josie missed 8 questions, how many did she get correct? Draw a tape diagram to demonstrate how you found the answer. Okay, so I went ahead and rewrote it as missed, but we could write the word incorrect. That's fine. But this is going to be our 2, and this is going to be our 9. Okay, I'm gonna make it into actual tape diagram pieces. So I'm gonna make my 2 small and my 9 bigger. Beautiful. So now we're gonna use the other piece of information that they gave us. If Josie missed 8, so we'd ask our students, okay, which of these diagrams do I need to add to? The top one. And I need to keep drawing pieces until I get to 8 total. So not 8 pieces, but the answers inside add up to 8. So here I would have another piece gets me to 4. Another piece gets me to 6, and one more piece gets me to 8. So I got to 8. Woo! Okay, but again, what we want our students to logic through is that they had to draw 3 more pieces. So that means we're going to draw 3 more pieces. Yes, they could just take 9 and multiply it by a total of 4, but they did say to solve it with tape diagrams. So we're going to draw the picture. And when I add all of these guys up, I get 36. So Josie missed 8. She got 36 correct. And then you'll notice down here it asks again a follow-up of how many total. So this is just asking an extra little bit to see if they are paying attention. They know what each number represents, logicking it through. Okay. All right. Next one. Tables. I'm a big fan of using tables. It's just my background as a math nerd that, especially at higher level math, you get XY tables. It's a nice way to organize your thoughts. And so there is a way to use it here for solving ratios. So as you can see, I've got 2 columns here. One column's representing girls, the other's representing boys. I have my first number of 3, and then my boys are 4. And the idea is each time that we go down the girl column, we're going to add 3. So each row, I have to add 3 for this side. So this side, we are adding 3 or multiples of 3. And this side, we are adding 4 or multiples of 4. Now, if we wanted to solve the previous question that we had about our 6th graders, where it said if there are 24 6th grade boys, use a table to find the number of 6th grade girls, there's 2 ways to do this. One way is basically to exhaust the whole table. You just sit and keep writing that table. So here we got 12 to 16. We'd want to go ahead and carry it through. 15. So I'm adding 3 on this side, adding 4 on this side. Do it again. And boom, this row now is going to represent our answer. Okay, so that's one way we can solve is just to follow down that whole table until we get to the row that relates to our problem. Or what we can also do is this is where we're starting to think higher problem solving. And that if I have 3 girls to 4 boys and I want to get to 24, okay, so this is basically asking how many times would I have to add 4? Okay, so 4 times what equals 24? Because remember, multiplication is repeated addition. So me adding 4 over and over again, this is saying 4 times what gets me to 24? The answer is 6. So that is telling me that I would have to have 3 6s to have both sides match up. So I added 4 6 times. I want to add 3 6 times. And the shortcut to repeated addition is multiplication. So here I get 18. Okay, we're going to try another one of those so that way you guys can practice it. So I'm going to do a new story problem, one where we just go through the table, fill out all the pieces, and another one where we do the shortcut. Okay, so you can decide which way you like better. Okay, so a homeowner is creating a vegetable garden in their backyard. They are planting one of their large raised beds using a ratio of 2 pepper plants to every 3 tomato plants. If they planted 12 tomato plants, then how many pepper plants are there? Okay, so we're talking about peppers and tomatoes. Now you'll notice up here they said peppers first and tomatoes second, but down here they switched the order. So that means we have our choice. We could either have the peppers first and then the tomatoes, or you could switch it. You could have the tomatoes first and the pepper second. So I just want to let you know it doesn't matter which one you have in the first column, but I do need the 2 to go under the pepper, and I do need the 3 to go under the tomato. So again, order matters as far as which number relates to which thing, but you can technically switch it. Okay. All right, if you're to there, we're going to now try to solve this. If they planted 12 tomato plants, so I need to get to 12. Okay. Over here, we'll try the shortcut, but for right now, let's pretend that we just have a student that just wants to power through, wants to just add, add, add. Okay, great. So the next row would be adding 2, adding 3. Adding 2, adding 3. Adding 2, adding 3. And we keep going until we get our magical spot. And so here we are. 12 tomato plants is relating to this row. So that means there are 8 pepper plants. Okay. Awesome. So that works. Boom. Go through the whole table. If you want to try the kind of shorter version that uses more kind of algebra skills, then we're asking, hey, I want 12 tomato plants. So how many times did I have to add 3? Oops. So they could sit there and add 3 over and over again, or think about 3 times what gets me to 12. So 3 times 4 gets me to 12. So to balance it out, I would have to add 2 4 times, which is the same thing as 2 times 4. So we got the same answer. Awesome. Okay. I think I've got one more for us. Let's see. In another large raised bed, they are planting 3 onions to every 5 potatoes. Man, they like to garden. If they planted a total of 24 plants, then how many of each did they plant? Ooh, this one's a little trickier. Okay, so let's start off with our 2 columns. So onions and potatoes. Okay, and it was 3 to 5. Now, if you pay attention, it didn't tell us how many potatoes or how many onions, like in the last problem when we were trying to get to 12 for tomatoes. It says if they planted a total of 24. Okay. So my suggestion, if they're talking about a total, is let's make an extra column. And this extra column is going to be our total column. So right now, if I have 3 onions and 5 potatoes, I have 8 total plants. Okay, so if I add 3 more onions, 5 more potatoes, then I'd have a total of 16 plants. Do it again. If I had another 3 onions, another 5 potatoes, I'd have a total of 24 plants. And I want to keep going until I get to the number that I want. And boom, I actually just found it. 24. This is my row. This is my row where my answers are. So here we would say that we planted 9 onions. The gardener planted 9 onions and 15 potato plants. Well, they didn't write plants up here, so we'll just go and 15 potatoes. All right. Is there a way to do this kind of sort of algebraically? It's a little bit messy, but yes, you basically would want to start the same way. onions, potatoes. Sorry that my tea got crazy there. And a total. Okay, you definitely still need the total. But what we would do is we would say, okay, I need to get to 24. So I would have to add 8 repeatedly 3 times or 8 times 3. So I have a total of 3 8s to get me to 24. So that would then tell me I would need to, oops, multiply by 3 and multiply by 3. Some of your sixth graders are going to be ready for the more kind of algebraic, fast, quick, logical thinking, and others just want to power through and do the table step by step. And for most problems, that's totally fine. Yeah, go for it. If it burns an extra minute or two, but it makes you feel better, do it. Okay, that's always the thing is we want students to have a positive math experience, having a good feeling. Okay, some last little thoughts before we leave ratios. There's a lot of great examples you can do in your class. So you could do the ratio of different eye colors. I just randomly chose brown and blue, but you can do brown and green or green and blue or gray or whatever. Okay. You can focus on physical traits like eyes, hair color, shirt color. You could do interests. You could ask, hey, how many people their favorite sport is soccer versus how many it's football or volleyball or, whatever it is. The number of students who have a pet versus those that don't. So you can create ratios and they don't have to be pretty. Just because everything we've done has been really small numbers, you could totally have a ratio that's like 17 to 12. Sure. There's nothing wrong with that. You can a ratio is just what it is. So if we found out that the number who have pets versus no pets is 17 to 12, fantastic. Totally fine. Okay. So there's also some fun things you can do. You can look at recipes. So if you are into like maybe baking, maybe you're going to do a bake sale at school, you can look at a cookie recipe. And maybe for one batch of cookies, you need 2 cups of flour to every 1 cup of sugar. I mean, obviously there are other ingredients, but you could just focus on 2. And then if you're going to increase the number of batches, then how does that affect your total number, right? Of flour versus sugar or whatever it is that you're looking at. You can also do cool art applications, mixing colors, primary colors. So when you mix red and yellow, we know we get orange, but what happens if we do 2 red to every 1 yellow versus 2 yellow to every 1 red? So different shades of orange, or you could even do different shades of purple or green, whatever you want to do. But yeah, you could definitely do some art applications. There's so much out there. Have fun with it. Challenge yourself to have fun with it and get your students excited. All right, that is it for our first lesson in Unit 4, which is on ratios. Our next video is going to be on rates with a focus on unit rates, so keep an eye out for that. And until next time, have fun with it. Keep working hard and enjoy. Always have a smile on your face when you're trying to do math. Good luck, and I'll see you next time.